Okay, grade 8, my apologies for not having this video uploaded last night. Completely slipped my mind. Anyway, it's up there tonight, so corrections are to be made. Just follow along. If you need to fast forward some questions because you got a lot of them right, just fast forward to the questions you got wrong and listen to the explanation. And try not just to write down what I say, but try and understand what it is I'm saying so that when you do your retest, you'll have a better understanding of what types of questions are going to be asked. So the first questions are true, false, and the first thing says a leg of a right triangle, like an isosceles right triangle, or any right triangle, can be the longest side. And we know this to be false right off the bat because legs of a right triangle are the two parts that make up, this is a leg, and this is a leg, and they are the two parts that make up the 90-degree angle. Those are legs. And the other side that connects the two ends of those legs together of a right triangle is called the hypotenuse. And every time, no matter what type of right triangle we're dealing with, whether it be a right triangle or an isosceles where those two are the same length, or a triangle that looks like this, or a triangle that looks like this, doesn't matter what the shape, the hypotenuse is always the longest side of any right triangle. So the first one, I think most people got it false. The second question says the sum, and sum of course means the answer to an addition, right, to addition. So the sum of the legs of a right triangle is equal to the length of the hypotenuse. And this too is false, and we'll explain why. So if I had a triangle that was 3 meters here and 4 meters here, and those are the legs, so the sum of the legs, so the sum of those legs would be 3 plus 4, and that would be 7. So that would mean that this distance here is 7 if this statement was true. And we know that's false, because what Pythagoras said is he said the sum of the squares attached to the legs, or the squares of the legs, which means if I square a leg, I actually take 3 meters, which is the side length, and I square it, and the area of this square would be 9 meters squared. And if I put a square or attach it to this 4, then the square of that leg would be 16 meters squared. And those two areas of the squares attached to the legs equals the area of the square attached to the hypotenuse. So 9 meters squared plus 16 meters squared would mean that this square has an area of 25 meters squared, and therefore would be 5 meters in length. Okay? So it's not leg A plus leg B equals leg C. It's the area of the squares attached to leg A plus the area of the square attached to leg B equals the area of the square attached to leg C. Question 3 says a square with an area of 400 meters squared. So I'm just going to draw that. It has an area of 400 meters squared. So for those of you who wrote this test and didn't draw the picture, a good strategy for attacking a question like this is to draw the picture and then visualize it. So if the area is 400 meters squared, then what you were supposed to realize is that the side length will be the square root of 400, which is equal to exactly 20 meters. Okay, but we're not done yet. Now that we know that the side length of this square is 20 meters, the perimeter would be all four sides added together, and 20 plus 20 plus 20 plus 20 would mean this has a perimeter of 80 meters, not 100 meters. So the answer is false, and that's why. Question 4, if squares attached to the legs of the right triangle have areas of 50 meters each. So let's just draw that. Okay, so areas of squares attached to the legs of a right triangle. So those are what it looks like. And each of these has an area of 50 meters squared. So we know that right off the bat that this right triangle is going to be an isosceles right triangle because the two legs are the same length. Because if they have the same areas, they must have the same length. And therefore, the length of the hypotenuse must be 10 meters. So let's see. If I attach a square to the hypotenuse, just in the last question we said, these two areas added together will be the area of this. So this area would be 100 meters squared for an area, and therefore its side length would be the square root of 100, or exactly 10 meters. So the answer is true. The side length would be 10 meters for the hypotenuse. Question 5 says a good estimation for the square root of 20. So again, I'm going to write the square root of 20 is 4.5. And we know that for estimations of square roots, we're going to use number lines. And the key to using number lines, since this is a non-perfect square, 20 is not a perfect square, what we have to do is determine which two perfect squares does the square root of 20 fall between. And I know that the square root of 16, which is 4, and the square root of 25, which is 5. So the square root of 25 is 5. So right off the bat, if I look at this number line, I can tell that the square root of 20 is going to be 4 decimal something. And the square root of 20 is actually 4 away from 16 and 5 away from 25. So it's a little bit closer to the square root of 16, but not much. Right in the middle would be the square root of, it would be 4.5. It was right in the middle of those two. Since the square root of 20 is just a little bit closer to the square root of 16, I could say a good guess would be about 4.4 or maybe 4.5. So is that a good estimation? Yes, it is. 4.4 and 4.5 is a pretty good estimation. The next one got a lot of people. So it says the square root of 20 squared is equal to 20. Well, the reason why this was a tricky question is you have to think of that as the square root of 20 squared is the same thing as the square root of 400. Because 20 squared is 400, so the square root of 400 is 20, and therefore this is a true statement. Question 7, you're given the squares of two numbers and asked if it's true. So 5 squared plus 4 squared equals 41. Well, 5 squared, when you square a number, it means multiplying it by itself twice. So this 5 squared is 25. 4 squared is 4 multiplied by itself twice, which is 16. So it is 25 plus 16, and 25 plus 16 is 41. So that is a true statement. Question 8, you're given a right triangle, and you're asked to find the length of the hypotenuse. So for this one here, I have two legs, so I'm just going to draw squares onto them. And I know that I'm not looking for the area because this is in meters, and this is in meters, and this doesn't have any units, but it's right on the hypotenuse. So I'm not looking for the area of the square. I'm looking for the side length of the hypotenuse. So the area of this squared would be 4 meters squared if its side length is 2. This would be 25 meters squared if its side length is 5. And therefore, the area of the square attached to the hypotenuse would be the sum of those two areas, which would make it 29 meters squared. But we're not done. That's not the answer. That's just the area of the square attached to the hypotenuse. So therefore, x would actually be the square root of 29, which is approximately, again, we need our number line here. Square root of 25 is 5. Square root of 36 is 6. So square root of 29 is right around here. So we could say probably 5.3, 5.4, 5.2, something like that. And if I use my calculator to actually calculate that, square root of 29 is 5.4. So a better guess would be 5.4, but 5.3 was acceptable. Okay. Question 9 is again looking for the length of the side, not the area of the square. So if I put my squares on here, I don't know this one, but I know this one. This is 16 meters squared, and this would be 25 meters squared. And remember, it's this area plus this area equals this area. So I have to figure out this take away this should tell me this, right? And therefore, 25 take away 16 is 9 meters squared. And if the area of the square is 9 meters squared, then the length of that would be the square root of 9 or 3. So it's 3 meters. Question 10, now we have a triangle given with the squares attached. This says 20 meters squared, this says 5 meters squared, so this one would be 25 meters squared. And I know I'm looking for the area because that unit right there is meters squared. So I'm not looking for the length of the hypotenuse, I'm looking for the area of the squared attached to the hypotenuse, x meters squared. So the answer for that question is 25 meters squared. For question 11, you're given an area, you're not given an area, but you're looking for the length of the hypotenuse. So the first thing I'm going to do is add up those two areas attached to the legs. And I know this is going to be 49 meters squared. And if that is the area of the square, then the side length, the x, is going to be the square root of 49, or 7 meters. A lot of people just put 49 and thought that was the answer. Remember, if I'm looking for the length of the hypotenuse, it'll just be on the hypotenuse itself. And I'm looking for the area, like this last question, it'll have a meter squared attached to it. All right, question 12. Is this a right triangle? Show why or why not. Okay. So I'll make it a little bit bigger. If we look at this question, we're given three side lengths, and if it is a right triangle, then it should follow Pythagorean theorem, which means the area, this is the side length, 4 centimeters, so this area here will be 16 centimeters squared. And if this is the side length, and this is the right triangle, this should be 144 meters squared. And if that's true, then these two areas added together, which is 16 plus 144, which is 150, 160 meters squared. The square root of 160 meters squared should equal 13.6. So I'm going to pull up my calculator and go to the square root of 160. And it's actually 12.6, right? So because it's 12.6 and this says the hypotenuse is 13.6, this can't be a 90-degree angle, because if it was, this would be 12.6 and not 13.6. So the answer is no, it's not a right triangle, because the area of the squares attached to the legs of the right triangle do not add up to be the area of the square attached to the hypotenuse. Question 13 is the exact same question, same idea. It's giving you a picture and saying, is this a right triangle? So here, I know this is the area because it's in centimeters squared, and I know this is the length of the leg. So for this one, I'm going to actually draw. So back to this question right here, what we really need to do is first find out what the square of 16 squared is, so that's 256. And if that's true, this is the area of the square. And if I draw a square onto this hypotenuse, this plus this will equal this. So 14 plus 256 is 270 centimeters squared, which means the length of that square would be the square root of 270, which makes this a true statement. Question 14 is just a missing leg of a right triangle. So if I attach my squares here, this would be 144, this would be 256. So 256, take away the square I know, 144, would be 211. So the area of the square is 112 millimeters squared, and therefore the length of the hypotenuse is exactly the square root of 112, or, since this is the square root of 100, which is 10, and this is the square root of 121, which is 11, probably right around the middle-ish or so, which would mean it's about, I don't know, anywhere from 10.4 to 10.6 or so. Somewhere in there is probably a good guess. Question 15, we have another right triangle. This time we're missing the hypotenuse, so I'm going to draw my squares. This is 144. This is 256. Now, believe it or not, about, I don't know, maybe 6 or 7 people can't add 256 to 144. So right off the bat, if I'm adding 200 and something plus 100 and something, I know my answer is going to be at least 300, right? But if I add this up, 6 plus 4 is 10. Carry my 1. 1 plus 2 plus 1 is 4. So therefore, the area of this square is 400 millimeters squared, which means the side length of that is going to be 20 millimeters. Question 16, what is the approximate square root of 108? And use a number line to show your reasoning. So if I take my number line, what two perfect squares is 108 between? Well, 100 is 10, and the square root of 121 is 11. So 100 is only 8 away from this, and it's, what is that away? 13 from this. So it's closer to 10, probably around 10.3, 10.4, something like that. And that's the answer for question 16. Right? It's in between, it's 10 decimal something, but it's closer to the square root of 100 than it is the 121. Question 17 is the easiest question on the test. What's 4 squared? This answer is 16. 4 multiplied by itself twice. What's the square root of, or what's 9 squared? Well, 9 squared is 9 times 9, which is 81. Question 19, what's the square root of 100? I think most people got 10. And what's the square root of 400? The answer is 20. Question 21 says, use prime factorization to determine if 1,000, correct, to see if 1,000 is a perfect square. So I'm going to write down 1,000. And the first thing I'm going to do is figure out that it's 10 times 100. Now, neither one of these is a perfect square. So 2 and 5 are both, this is a prime number, right? 2 is a prime number because it only has 1 in itself. It can't be broken down into anything else but 1 in itself. So those are prime factors of 1,000. So what that means is 2 multiplied by 5 multiplied by 100 would be one way to get 1,000. Or 2 multiplied by 5 multiplied by 10 multiplied by 10 would be 1,000. And if I break this further down, I can go 2 and 5 and 2 and 5, which means 2 times 5 times 2 times 5 times 2 times 5 is a way to get 1,000. Now what we do with these prime factors is this, is if we can rearrange these into 2 equal groups. So I'm going to put a 2 over here and a 2 over here and a 2 over here, and I only have 3 2s. That's as much as I could do, and a 5 over here, and let's do 2 5s over here. When I look at what these two numbers are, they are not identical. This would be a 20, and this would be a 50. So one way to get 1,000 is 20 times 50. But I can't make 2 equal groups here, which means I can't make 2 factors which are identical to give me the product of 1,000, which means that 1,000 is not a perfect square. Now the next question says use prime factorization to determine if 484 is a perfect square. So again, I'm going to put 484 here. And since it ends in a 4, I know that 2 is a factor, and that will be 242. And since this ends in a 2, I know that 2 can come out of there, and that'll be 121. And some of you left it there, and you forgot that 121 is actually the product of 11 times 11. Now when I look at those circled prime factors, 2 times 2 times 11 is 484, I can rearrange those into 2 equal groupings, which means that 22 times 22 is one way to get 484, which means that 484 is a perfect square. And if I go ahead and take that, and take 22 times 22, it equals 44. So yes, it is a perfect square. Question 23 says, what is the approximate length of the diagonal? Well, if I take this shape here and bring it down, I have a right triangle. The hypotenuse I don't know. This is 6 meters, and this would be 9 meters. So when I extend squares onto all of these, this would be 81, this would be 36, and this would be the sum of those two, which is 110, 117, is that right? And therefore, the length of the diagonal will be exactly the square root of 117, or approximately, I'll take my calculator out, probably 10.6, 10.8. It's approximately 10.8. And question 24, the hardest question on the test. So there's a wall, and we'll call this the wall. We don't know how high up this water, but we know that a ladder, when leaned against the wall, okay, so there's my ladder leaning against the wall. We want to know how far up it can go. And they give you two distances. They give you a wall with let's see, there's 80 centimeters for this one. And this one is 1.4 meters, which we're going to change to centimeters, so 140 centimeters. So when I draw my two pictures, the first one is 80 centimeters from the wall, and the other one is 140 centimeters from the wall. And if you really think about it, the question says, what is the highest distance the ladder can safely climb? So of the two pictures, the closer the ladder is to the wall, the higher up it's going to go. So I know that of the two pictures, this is the picture that I need to focus on, okay? So we know that the ladder is 4 meters, but since this is in centimeters, I'm going to change my 4 meters into 400 centimeters. And what I'm going to do then is I want to know how high up the wall it can go, so that is my x. Now if I take this picture and translate it into a right triangle, I have 400 as my hypotenuse, I have 80 as one of my legs, and I have x as in the maximum distance going up the wall. So if I then take my squares and draw them on all of them, 80 squared is 8 times 8, which is 64, plus 2 zeros. 400 times 400 is 16, plus 4 zeros. And x squared would be that. So once I realize this is the area of the square, this is the area of a square attached to the leg, and this is the area of the hypotenuse, this one right here is going to be 153,600 centimeters squared. And if that is the area of the square attached to the wall, then the length of the wall will be the square root of that number. So therefore, the square root of 153,000 600 is the distance up the wall it can travel, which is 391.9 centimeters. So 391.9 centimeters, or approximately 392 centimeters, is the answer for the question. So what I was looking for was A, drawing a picture that looks like this, B, translating it into a right triangle, showing me your work, and getting the answer 391.9.